I'm Rosemary Wang, a developer advocate at HashiCorp, and today I'm talking about some HashiCorp Terraform specifically for network infrastructure as code. I know that Millar referenced this framework or this journey, and yes, it is simplified. Sometimes you're going to be in the gray areas between each of these stages, but today we're really going to focus on some of the important components to adopting infrastructure as code and frame it around network specifically. So we're going to focus on adoption, and we'll talk about standardization and scale later on. The first thing is that there's a lot of practices that you have to have in place when you start talking about infrastructure as code, right? When you define infrastructure as code, are you actually defining it as code? Is it configuration? What is it? Regardless of how you approach it, there's some common practices that we think about before we start writing or start typing on our keyboard. One of these practices is making sure it's declarative, right? Making sure that what you declare to be your resource state is actually what the resource is going to be configured to be. It is not how you're configuring the resource, but what you're configuring the resource. You also want to think about maintaining the code and state. It's not as simple as saying I'm going to write a configuration and provision all these resources. It's a lot more complicated than that. And we'll talk about injecting dependencies as a practice. This is something I like to borrow from the software development space, but I think it's an important component to decoupling resources and mitigating impact. We all know that the network is a lower level resource in which a lot of other resources depend on it. So it makes it important to decouple it even further, especially if you plan on making changes to it. All right, so let's start with declarative practices. If you're not so familiar with Terraform, this is going to be a very rapid overview. But Terraform is a declarative domain-specific language that offers you the ability to configure infrastructure with specific attributes as well as resource descriptions. This means that you define the expected state using configuration files. And these configuration files you can version, reuse, and share as you need to. The main difference between declarative versus imperative is declarative describes what the end state should be. Imperative describes how you're going to get to the end state. So this changes a little bit, right? We think about network as code. Network as code typically refers to the configuration of specific network devices. So this could be something like an imperative interface, whether it be configuring a switch interface, something else. Comparatively, the thing about Terraform that you have to recognize is that it's not necessarily going to configure the switch itself, right? There are sometimes opportunities for you to do that. There are some plugins that allow you to do that, but Terraform itself is actually focused more on provisioning and sort of the general systems level reflection of what that configuration should be. It's not going to be per switch. It's not going to be per device. So that's one thing I do want to get straight, because some folks are like, why would I use Terraform when I could already be using Chef, Salt, something else, right? So this is the important part about Terraform. It is intended to configure the end state of a system level, at system level, not necessarily per switch level. Although you can do that if you really want to. So if you have not seen Terraform before, Terraform has a couple important components to it. The first are providers. Providers are plugins that allow you to interface with a target API. In this case, I'm able to interface with a target API in the form of Cisco ACI. So here I have configured the plugin. And then when you configure the plugin, you also need to add the username and password, or how you're going to access that API. Most APIs are secured, so you do need to pass in some information for Terraform to authenticate to that target endpoint. After you've configured this, you can start by initializing Terraform. When you initialize Terraform, it downloads the plugins and it creates something called a backend. The backend stores the state that Terraform is going to use to reference how it's going to configure everything next. So when you initialize the backend, that typically is going to be local unless you specify something differently. So it's a local file. You're also going to get a bunch of plugins installed as well. And some of these plugins can be networking, it could be compute, could be storage, whatever plugin that you are looking for, as long as there's a community or a vendor who is supporting the plugin and able to write the plugin to interface with the target API. All right, so the next thing that we're going to do is configure a few things in Cisco ACI. So here I've got a tenant, application profile, and a verb. This is more straightforward in terms of configuration. I'm going to do an apply. The Terraform apply step has a manual pause. So it will evaluate what resources need to be configured. So in this case, I have an ACI verb. I have a bunch of attributes that I want configured. And Terraform will tell me, okay, I can configure them. That's great. But do you really want to configure them? And the reason why there's a manual pause here is most of the time you do want to review what infrastructure is going to be configured. You don't want to accidentally delete something that you don't want deleted, right? Especially in a networking situation, you might have specific pieces or components of the system that you want to target or you don't want to necessarily destroy. So you want to evaluate what that plan will be before you continue forward. So here we're going to say yes, because why not? We're bold. We're going to change the ACI configuration here. And let's see. All right. So Terraform will create all of this, and this is through accessing the API on the Cisco side. I'm going to scroll through this one. Some applies will take longer than others. So if you are working on, let's say, a target API that takes a little bit longer, you'll notice that it will take a lot longer to execute some of these operations. So in this case, I'm doing a replacement, and that's because I'm renaming something. Each plugin or each provider for Terraform has the logic for whether or not something needs to be fully replaced or needs to be updated in place. So that is something on the provider side that logic has to be captured, right? So everything that you need to do against the API is going to be captured specifically in the plugin. That's very rapid introduction to Terraform. But if you are interested in specific providers, you're curious to know, okay, what else can I configure using Terraform? We have the registry that Laura mentioned, registry.terraform.io, and there are public providers out there. Some of these providers are maintained by the vendors or the organizations that have maintained the APIs. So for example, Cisco, Palo Alto, some of the others. Other times you'll find community providers. As a note, definitely use at your own risk. Right, from a security standpoint, these are providers that are often interacting with APIs. You're going to provide credentials to it, so make sure you vet the providers that you're planning to use. All right, so the next practice we're going to mention is maintaining code and state.
Hey, Rosemary. This is Chris Grundeman. I just want to jump in real quick. I think it might be worth diving a little bit more into like what a provider is. I get that we can kind of use them to interact with other vendors' equipment, but it might be worth talking a little bit more about how that works, right? I mean, my understanding is pretty limited, and I think it's basically an API interface that's kind of handled for you, but maybe you could go over that in a little bit more detail for us.
Sure, of course. So each provider is written in Go. So it's effectively treated as a client or as a server, and the Terraform is a client. So what happens is that Terraform doesn't really know what to do with a target API, Terraform itself. So if you go online to HashiCorp.com and you download Terraform as it is, that binary doesn't really know what to do. It needs some, I guess, intelligence or logic to understand how to orchestrate against an API. So a provider itself is a binary. It's compiled using Go. And what it's going to do is it's going to list a set of create, read, update, and delete commands against a target API. So there's some structure in place. There's a SDK that you can use to build the create, read, update, delete sequences. And whenever someone develops a provider, they capture all of the logic that needs to go into interfacing with the API. So it could be authentication, but a more complex kind of operation might be, okay, if I create a verb, right, I need these attributes to send to the API. So I'll capture these attributes from the user and pass it for you and proxy it to Terraform to pass it to the API. There are other complex operations that you might include within a provider. So for example, maybe you want to check that the application profile exists before you create the verb. That kind of logic is something that's also captured in the provider. And the reason why this is important is that Terraform is offering a declarative layer on top of imperative programming language. So if you think about automation, network automation in general, right, you might just say, okay, why can't I just write a Python script and go, make a verb and make something else, put a profile together, right? It's important for Terraform to recognize the order of operations, as well as provide a stable way for someone interfaces with the API, right? Because if you're trying to automate something, you want predictability and you want some stability in how it plans on interfacing with it. Does that provide enough context around providers?
Yeah, that makes a lot of sense. So to kind of summarize, I mean, a provider is a big part of what makes this from an imperative process into a declarative process, because it's kind of the provider is being provided by whoever, usually the whatever software you're interacting with, in order to kind of manage their API. So they're giving kind of the instructions, and that way, because I know that like if you're home brewing this, like you said, right? If I'm not using Terraform, if I'm trying to write this myself, I'm often having to update my code whenever an API changes, right? Because somebody releases a new version of code, but the provider handles all of that for us. Is that right?
That's correct. Yep. And
Okay.
usually the providers are updated. Usually we work hand in hand. So if with the person, the API provider, right? So if let's say it's AWS, we're usually working with AWS to make sure that the resources that they're offering are up to date, not just on the AWS API side, but also on the Terraform side as well. So if let's say a provider, caveat to this, if a provider is community maintained and someone doesn't have time to make those API updates, then perhaps your provider will be out of date as well. But I think the bulk of a provider's value is offering a lot of these logical steps that you don't have to capture yourself. Instead, you can just defer that to the provider.
One of our other networking field day delegates from previous years, Bruno Wollman, he's asking if you can go deeper into where you would use Terraform over something like Ansible and where they work together, because Ansible has Terraform collections.
That's a great question. So you usually use Terraform with Ansible as sort of a two-step process. So the first is, let's say I want to provision a virtual switch somehow, right? So I'll provision the virtual switch using Terraform, and it will provide some attributes as, where is it from an administrative standpoint? So if I have some kind of SDN Google product or something, I'll use Terraform to create sort of the logical grouping of, okay, here's a tenant, here's this configuration from an administrative standpoint. Here's which users have access to doing these things. And then here's the actual switch itself. Oftentimes, Ansible is used as a second step to say, okay, now that I'm on the switch, I have to configure all of these interfaces. Some, as SDN and other kind of networking tools, allow you the ability to declare it upfront, right, on Bootstrap, right? So when you say, I want this switch, I want XYZ interfaces configured immediately. Other times, other devices don't have that ability. So Ansible comes as a nice second step to that, where you say, okay, I want to get onto that device and configure those interfaces properly and make sure they're configured in the way to connect to other things, because maybe I'm waiting for other switches to come up too. So Ansible is usually the second step process. The Ansible does have the ability for you to configure or to provision resources as well. Sometimes it depends on the configuration. Both do work, but most folks tend to start with Terraform because of the ecosystem itself. As Malorm pointed out, there's a lot of tools and platforms that we have to interface with now. Terraform's ecosystem allows you to go look at it from a larger systems level and say, okay, if I need to provision a network in AWS, I do it here, I do it XYZ, and I can connect it to my switch on-prem, and I'll use Ansible to configure the switch itself on-prem without necessarily needing to handle the provisioning portion of that. So a lot of the folks who use Terraform are using it from a systems level. They're using it across many, many different platforms. And with Ansible, they're focused on specific configurations or specific on-device configurations that they are looking to create and cannot be done at startup. So there's a couple different ways you could do it. Okay. I'm going to move on just because we got a short section here. This is the intro section. But the next practice we're going to focus on is maintaining code and state. We talk a lot about using a source of truth in infrastructure. And over the years, we've thought about saying, okay, we want to make sure that everything that we know about our system is correct, right? So we need some kind of source of truth. This is important from not just a chargeback perspective, but also just from a general systems view. Anytime you do automation or changes, you're going to rely on that source of truth. And so maintaining code and state is important because code and state becomes your source of truth. When you establish a source of truth with Terraform, what you're really saying is that this configuration is the established configuration that I want to use across, whatever it be, across my system, across my network, whatever device you're trying to configure. So In this situation, it's easy to say, I'm going to create this tenant and I'm going to store its state locally because I've only run it on my machine. This is how we typically start with Terraform. We say, okay, we're going to just run Terraform apply and things get stored locally. It's great. And this is where we get the argument of it works locally, but it doesn't work on someone else's machine. And so in order to prevent any conflicts from state, making sure that you establish that source of truth, and if you accidentally, for example, delete the state file on your machine, you can configure what is called a remote backend. So in this case, I'm configuring Terraform Cloud as a remote backend. I'm declaring an organization that I belong to, as well as the workspaces. And what this will do is take the Terraform state generated and save it up to a remote backend. A remote backend is really important, especially if you, let's say, do kind of multiple machines, you develop across multiple machines, you have many people collaborating on that. Or more importantly, you're planning to automate the apply step for Terraform, right? So if it's not going to be on your machine, it's going to be on a CI framework. You do want to create a remote backend, and that remote backend serves as a source of truth. So to show that a little bit, what I'm going to do is take the automation that I did have, and I'm going to just move it to a remote backend. So if I print out what I have locally, I have a local file called terraform.tfstate. This is a JSON file that captures all the information about the resources I configured. It has sensitive information, so I won't print it on screen. But what I want to do is take this state file and push it to somewhere remote. And the reason why is that if I delete that state file, I have resources hanging out there that I don't even know about, Terraform doesn't know about, and now I have to go back and look for them, right? I have to reconstruct everything. So what I'm going to do is go into Terraform Cloud, and in Terraform Cloud, I'm going to create what is called a workspace. A workspace sets up a backend for any resources that's created by Terraform, as long as I point to said backend. There are many other kinds of backends that you can use. You can use buckets, object stores, different databases, but Terraform Cloud offers a pretty easy way for you to just set something up and store it there. You can also just store state there. That's on the free tier. You can just store state. You can also run Terraform in Terraform Cloud, but we're going to focus on just storing the state. So I'm going to do a couple tags on here. And the reason why I'm going to tag this workspace is that it provides some metadata as to how I plan on running it. In my case, I'm maybe just starting out on this network infrastructure as code journey. So I'm just going to tag it, making sure that I describe a source CLI. So I'm running the Terraform apply through my local CLI, and I'm going to label the location as well as what purpose it has. And this is a great way for me to search on it. It's also a good way for me if I have many, many, many more of these networking configurations that I need to put somewhere, I have a way of sorting them out within Terraform Cloud. So when I try to initialize Terraform next, because I've described this new remote backend, Terraform will tell me that I need to migrate my state. So remember, it is local, it needs to go remote. So when it goes remote, I get this nice prompt that says, please, let me know, should I actually be copying it? In which case, I'll copy it over because I want to preserve my state. The reason why I want to preserve state is that if I delete the state, then I have a bunch of devices hanging out there that I don't know about. I have a bunch of resources that I'm no longer officially managing, and now I have to go look for them by myself, right? I don't have a source of truth anymore. Instead, I have to go reestablish a source of truth in my target API, whether it be Cisco ACI or AWS. So we're going to continue doing that. And once I start my first run again, there we go. Once I start my first run, what will happen here is that the first run will go into Terraform Cloud into what is called a remote apply. And a remote apply means that Terraform Cloud handles the apply of Terraform for me. I don't have to have anything special on my machine to do it. It will just handle all of the provider download as well as the configuration. And remote apply is kind of nice because sometimes it takes a long time to apply resources. If you are trying to create a network or you're trying to create some complicated database configuration, for example, sometimes you'll end up sitting there waiting for 15, 20 minutes to configure something, and your computer will have shut down by that point, or your battery dies. And in which case, Terraform will stop. You don't have you don't have this source of truth anymore. Instead, you sort of have some middle ground of configuration. So when you have a remote apply, what that will do is reestablish the source of truth on the remote backend, but also make sure that if, let's say, your computer shuts down, the Terraform Cloud will maintain that run for you, so you don't have to think about it. Let's see if this will, okay, here we go. All right, so the next important part about Terraform and code in general is making sure that you have the ability to support a CLI-based approach and a VCS-based approach, or version control approach. The reason why both are important is that there are some devices and some resources that you'll configure that you won't really want to be committing to version control, or you don't want to automatically have version control configuring it, because maybe there's some custom automation that you want to add in place, right? So a good example of this is maybe that you have a switch that's only accessible through a VPN on your machine, for example, and you need a way to configure that properly, and you want to do it through Terraform, in which case you can do the Terraform CLI. You don't have to do it through Terraform Cloud. But alternatively, for cloud resources, we've moved toward a model where we commit all of our changes to version control, something like GitHub, and we push those changes. Once we push those changes, then have something automatically pick that up and apply it for us. So in this case, Terraform Cloud does offer a version control mechanism. You can say, okay, in this workspace, which I'm deploying some cloud resources to AWS, I'm going to configure my repository. I'm going to configure how I want it to apply, when I want it to go, where it's going to be, how I'm going to connect to VCS, which working directory I want to be in. And there's also some other configurations that you might have about, let's say, when it should run. Maybe you only want it to run on certain folders, which is where I just want it to run on cloud. There's a lot of settings here you can do for version control. There's also additional settings on pull requests. So if, let's say, you're collaborating with someone else and you make a pull request, then Terraform Cloud will do something called a speculative plan. So we'll check that the pull request is accurate before you merge that pull request in and then commit that up. We're not going to go too far down into the infrastructure as code with version control discussion. This is just an overview, but once I make a commit and push this to Terraform Cloud, then it will start its first run. More importantly, when you use Terraform Cloud, especially if you use it in this automated way, you have to define a bunch of variables for Terraform to work, right? Terraform needs access to target APIs. So you do need to add some declaration of where you're accessing the target API, whether it be secrets, it could be network information that you might need to add, some attributes that you want to configure. You do have to establish those variables at the workspace level. There are also alternatives where you can do something like a terraform.tfr locally, push that up to version control, and Terraform Cloud will automatically pick that up. But for something like secrets, right, for providers, for example, in this case, I have AWS and I have Azure, I want to make sure those credentials are secret, so I will put them into Terraform Cloud as sensitive variables. I won't be committing them to version control. Just to be on the safe side, what I'll do is I'll just add that in and mark them as sensitive, which means that people cannot read it. I can only write to it. So every time I configure, if I need to configure new credentials, I would come into Terraform Cloud itself and set those variables and make sure that they're secret. So this is the final step, right? Let's say I made some changes through version control. I do a git push, and once I push, then Terraform will have a webhook. Terraform Cloud will have a webhook that says, okay, I see that you have this commit. I'm going to apply those changes. I'm going to plan, and then I'll let you decide whether or not you want to apply those changes. So the reason why we're skipping through this is because sometimes plan takes some time. Again, it's making calls to a target API. So it will make a lot of calls to the target API, and it needs time to return the information to you. So once I say I'm ready to apply, I can just go into Terraform Cloud and apply. I can similarly also use the, not in the case of VCS, but if you're using the command line, you can use the manual yes on the command line. If you want to make sure that your workspace always runs, I got that. If you want to make sure that your workspace always runs and always applies those changes, you're not going to wait for that manual step. There is a configuration in the workspace that allows you to auto apply. So if you are saying, I just want someone to just apply these changes all the time, I don't want to wait for someone to type yes or to say yes in the console, you can say, I'm just going to auto apply it. Use at your own risk though, because maybe you haven't tested it, right? And tested the changes. Make sure that you are confident that whatever changes you're pushing out is actually something that you want to automatically deploy. So that's maintaining code and state and maintaining a source of truth. The next is a little bit more complicated, and that's injecting dependencies. Injecting dependencies is a difficult thing to describe, but basically what you're trying to do is retrieve metadata from some abstraction to change your downstream dependencies. Why is this important? If you try to, there's two principles to dependency injection, one of which is what is called the Hollywood principle. I'll call you, you don't call me. So your higher level resource needs to call information about the lower level resource. You never want to say, I'll use the lower level resource to push information to the higher level resource. A great example of this might be, okay, I have a server and a network. A server is considered a high level resource because it depends on the network. A server should pull information about the network. The network should not be pushing information to the server, right? Because it doesn't scale well. When you have a lot of servers on one network, then that network is responsible for pushing a ton of information to any number of servers. So the result is that there's usually some confusion when it comes to automation. There's some instability there. There's not terribly a reliable behavior that you can expect, because what happens when a new server joins? So what happens if it's just a defined interface that someone is connecting somewhere else that has nothing to do with the server? So what that principle is making sure you're doing is a unidirectional dependency. So a server that depends on the network is going to retrieve the network's information by itself. It's not going to expect the network to push that information to it. The second part of dependency injection is adding an abstraction. So rather than a server calling the network itself and saying, IF configs, whatever it config on the machine, it says, give me my IP address or give me the CIDR block that's associated with it, because a server might not have that information. What you'll do is you'll have the server retrieve the information from an abstraction layer. In this case, that abstraction layer is Terraform. So if you're familiar with Terraform and you're curious what this actually looks like, well, what we're doing is that our abstraction layer is actually an API. So it's not necessarily the server itself. It's not necessarily Terraform. It's the AWS API in this case. So in this example, maybe I just want to know what availability zones are available to me in this region. So I'm going to use what is called a data source. A data source serves as the abstraction to call the AWS API for me and dynamically get a list of available availability zones. Say that 3 times fast. And what I'll be able to do is take that into a resource, a dependent resource like a subnet, and say, okay, this higher level resource called the subnet needs this information about the availability zones. I'm going to use that information. I'm going to call the AWS API, get it, and then I'll configure myself appropriately. The trick with this is that you need to choose the abstraction and you need to choose where these resources are calling each other. You do not want a circular dependency. So for example, I don't want the availability zone to call the subnet for information. Again, you want a unidirectional dependency because it makes it a lot easier to configure for automation. It also decouples any changes that you might make on one resource from another. It's a quick introduction to dependency injection. And it's actually a lot more complicated than that in many situations. But I think when you have this bridge between data center and cloud resources, it's not quite so easy to say, I'm going to decouple the resources that I need from my data center to the one in cloud. It's also really complicated when you have, let's say, devices that are not configured by Terraform. So there's that interesting boundary between what is configured by Terraform and what's not configured by Terraform, because not everything can be, right? So if you've got a switch that maybe you're just never going to configure with Terraform, you still maybe want information about it. And so what we're going to go through is the use of a data source and a provisioner to show how that works. So I'm going to use a data source. This is the HTTP data source, and it's going to retrieve information from the switch API, NSO API specifically. So it's using the Cisco NSO API, and it's going to retrieve information about devices. And the reason why this is important here is I don't need to access the switch directly to get the information. Maybe I have another source of truth or another database somewhere that has the information for me. I'm going to make a call and treat that database or that source of truth as an abstraction. So I'm going to start with that first. So once I make that API call, I'm able to get information about maybe the list of devices or some of the other things that I want to configure. And specifically, I want to get some information about a host, a switch, a router that I have configured and it's in that inventory that I know it exists. So I'll do a bunch of parsing. We're not going to go through the logic and syntax of Terraform today. But if you're curious about the syntax, I'm basically parsing through the return response from the response from the API and making sure I can get the IP address. And I'll use that to configure my switch on the switch itself. Now, the switch has to be configured with SSH. That's one of the things about provisioners that you have to recognize with Terraform. Terraform provisioners are going to log into the device that you want, specifically the remote exec provisioner will log into the device you want and run scripts and run automation. So here, what we're going to do is just run a file just to say, okay, here's the device. And then eventually maybe I'll run a script for automation. You could load a Python script if you want to. You could do something else if you would like. But what this is going to do is log into the switch, and then it's going to run the automation that I like after I've gotten that information. And the reason why this is important is that I'm decoupling the configuration of the low-level switch that I want information about from Terraform, which is configuring something else, right? A higher level resource. Provisioners are used as a last resort. So it's not something you want to do on a regular basis. But if you have a boundary between something that's not Terraform managed or Terraform configured, and you need to configure a Terraform resource that depends on that, a provisioner might be a way to go. There are other ways that you could possibly do this that you probably want to start first. But this is often a pattern that I see, especially with devices that may or may not be API enabled, or they may not be part of Terraform to begin with. So if you are curious to learn more about Terraform, you can go into the Terraform language documentation. The Terraform language documentation contains all of the functions and the configuration blocks that you'll need. There are a huge variety. They're not necessarily specific to providers. You can use the configuration language to do a bunch of internal logic, parsing CIDR blocks, anything else that you want to do. The provider itself provides the logic to orchestrate against an API. The configuration language allows you to retrieve information about that API specification that have been defined in providers. So that's a quick overview of Terraform. So we went through all these practices. We're trying to go through this as quickly as possible, but hopefully this provides a general overview of some of the practices that you'll need as you start to write network infrastructure as code. We took a look at some more specific use cases or examples where you have to consider building these bridges between something that's not Terraform managed or automated and something that is Terraform managed and automated, especially because we are supporting a lot of platforms and a lot of environments. It becomes really important to establish code and state as a source of truth. Make sure that you're declaring and defining what resources should be. That way it has a stable logic for how it's going to be automated and configured. And as you decouple resources, it provides it a lot easier later on for you to evolve that system.
I'm looking at your providers, and I see that a lot of them are by Cisco DevNet or by the company, but then I see others that are by an individual. Do y'all go through and verify those providers' work, or how does that process work?
So we do not. There are some providers that are vetted for or verified in that they are supported, right? Meaning we do know that the vendor or the individual is actively supporting them. There are others that we label as sort of community providers, and we do not necessarily know if those community providers are up to date. We also don't know who's maintaining them actively. Terraform has the ability for anybody to create the providers and put them onto the Terraform registry.
So you use them at your own risk, basically.
Yes,
I noticed that there's a partner for the ones that are done by the company. There's a partner tag on there. So
yes,
at least that makes it easy to notice.
Yes, that's correct. It does make it a little bit easier. So I think that those are the ones that usually have partner teams supporting them.